seen last time. These are the derivative rules, right? Derivative rules, differentiation rules. Okay? These are the rules we have seen. We have, did we see the derivative of cosecant or not yet? Did we see cosecant? Did we do it? So we did all the trig function, cosine, sine, secant, cosecant. Did we do it? We didn't do cosecant? Did we do it? I mean, how do you do it? If we did not do it, how do you do it? How do you suggest we take the derivative? We did all the trig derivatives, right? What's the derivative of cosine? D by dx of cosine x is minus sin x. D by dx of sine x is cosine x, right? D by dx of sin x, what is that? Secant squared x. D by dx of secant x is what? Secant x tan x, right? D by dx of cosecant x, what is that? Did we do it or not? No. We didn't do it? Let's do it. How do you suggest we do it? What is cosecant? Cosecant is 1 over sine. Let's do it here. Cosecant x prime is 1 over sine x prime. This is just minus derivative of sine, so it's minus cosine x over sine squared x. So what is that? Let me write this as minus cosine x over sine x times 1 over sine x. So what is that? This is just minus cotangent x over sine cosecant x. I hope it's right. Minus cos x cosecant x. And we did the derivative of cotangent. The derivative of cotangent is minus cosecant squared. Is that what we got? Yeah, we did that? Yeah, did you do it or not? We did it, right? D by dx of cotangent x is minus cosecant squared x. I don't have them memorized, so how do we memorize it? How do we derive it again? Cotangent x prime. What is cotangent x? This is cos, this is cos over sine x prime, right? What is that? Cos x prime, what is the derivative of cos? It's minus sine x times minus sine x minus the derivative of sine is cosine x times the top over sine squared x, and you get it's minus cosecant squared x. Very easy thing now, the power rule, d by dx of x to the n. What is that? This is n x to the n minus 1. This is power rule, right? Power rule and real number. And what else did we see? D by dx of e to the x, what is that equal to? E to the x. Okay? I know I can see more derivatives, but these are the things that you should know. I'll try to keep them for now. I'll try to keep them, yeah, these can be read, I think. Very good. I'll try to keep them here, and I'll try to stick to these two boards. So in case you need them. Of course, I assume that you will know these, at least these formulas by heart, right? These you should know by heart, okay? I mean, it's not very, did I mess something up? I don't think so. Great. Now, what we were doing last time, we were doing the tangent line. Okay. Let's look at the tangent line. Right down here. Tangent line to y equals f of x at a f of a. So if f is differentiable at a, an equation of the tangent line to y equal f of x at the point x equals a is, what is the slope of the tangent line? F prime of a, right? So how do we know? We know that we derive the equation of a line. So it's y, f prime of a, times x minus a. Now, when x equals a, what is the y value of the point? Right? The point is common to the tangent line and to the curve y equal f of x, right? What is the value of that? What is the y value of that point? If x is equal to a, then y is equal f of a, right? This is the equation line. This is the equation of the line. Y is equal to f prime of a times x minus a plus f of a. The normal line to y equal f of x as the point a f of a is the line through a f of a that is perpendicular to the tangent line to y equal f of x at a f of a. Okay, we also derived an equation of this line. If f prime of a is non-zero, what can I say about the product of the two slopes? If I have two perpendicular lines and the slopes are non-zero, what is the product of the two slopes? -1, right? So, what is the slope of the normal line if f prime of a is non-zero? Y is -1 over f prime of a times x minus a plus f of a. Okay? Great. These are the equations of the line. You should be comfortable with these. Okay? You should be comfortable to derive an equation of a line. In how many ways you can do it, right? There are many ways you can do this. So, great. Awesome. So please get familiar with this. If you're not, you're supposed to be familiar with how to find an equation of a line given the slope and a point, given 2 points. Okay? So you should be able to do this. Okay, great. Now, if f prime of a is 0, what can I say about the tangent line? What can you say about the tangent line? The slope of the tangent line is what? Is 0. Very good. So what can I say about the tangent line? It's horizontal, right? Everybody, if the slope of the tangent line is 0, right? Let's look at this, for example. Right? The tangent line here is horizontal, right? If f prime of a, the tangent line is horizontal. So what is the normal line to the curve at that point? In that case, the normal line is, in that case, very good. In that case, the normal line is, what is it? If this is, the tangent here is, let's not, well, I don't know how to it here, but anyway. Yeah, well, that's it, right? That's the normal line in that case, right? This is the tangent line. And this is the normal line. So in that case, the normal line is vertical, right? What's perpendicular to horizontal? Vertical, right? Now I have a f of a here. This is the point, a f of a. The equation of the tangent line is y is equal f of a, right? Because f prime of a is 0. You see that? Now, what is the equation of the normal line in that case? It's a vertical line, so it's x equals something. Do you agree or not? Everybody, do you agree? So x equals something. If this normal line goes through the point x equals a f of a, goes to the point a f of a, what is the value of the normal line? What is the equation of the normal line? It's x equals a. So here it's y equals f of a. and x equals 8. Awesome. I'm tempted to erase this, or to erase this, but that's, okay, so far so good. Please be familiar with how to derive equations of two lines perpendicular to each other, I don't know what. Okay, you've seen this, right? I assume you've seen this before. You should be very comfortable with this. If you're not, please remind yourselves, or I can post some notes or something, or ask the TAs to go through it. Let's see what happens. Anyway, great. Did you copy down everything? Yeah, did you copy everything down? Yeah? Great. Awesome. I'm tempted to erase this. Is it fine if I erase this or no? I keep them. Because we'll use them. What do you prefer? Did you guys memorize these or not? I can erase it? On the left side, can I erase it? I'll keep it. Okay. Some want it. Okay. Great. Okay, anyway. But that's not to discourage you of not learning them. You should know these by heart. I personally know these two by heart, cosine and sine. And then the rest I derive. And I know this one and this one by heart. Okay? So the rest I derive everything. Anyways, so what's the derivative of cos? Minus sine. What's the derivative of sine? Cos. So you're good. Okay. If you have these two, then you're fine. Anyways, great. Let us do some problems. Okay. Find the point on the curve y is equal, let's see, what do you want? Let's pick something nice. Well, let's pick something easy. E to the x minus 5x, where the tangent line is a parallel, let's see, no, this is horizontal, let's say, be parallel the line. Let me check. I don't know, 17x minus y is equal to 72. And let us try to do these questions. Okay, so I have a curve, y is equal e to the x minus 5x, and I'm looking for the points where the tangent line, I have a curve, right? And I'm looking at the points where the tangent line is a horizontal. Now, horizontal, what does it mean? What can I say about the slope of the tangent line if it's horizontal? Everybody? 0, right? So, and what is the slope of that tangent line? How can I find the slope of a tangent line on an arbitrary point? By taking the, everybody, this side, yeah? Are we good? Yeah? So, for A, dy by dx, what is that equal to? This is just dy by dx. Who wants to help? Please raise your hands. One by one. Someone else? Someone else? Someone else? Yeah? E to the x minus 5, thank you. E to the x minus 5, great. So, I want to solve dy by dx is equal to 0. What do I get? E to the x minus 5 is equal to 0. Then e to the x is equal to 5. What is the solution to that? X is equal to ln 5, right? Now, at the point where x is equal to ln 5, the tangent line is horizontal, right? Everybody? Yes. Now, if x is equal to ln 5, what is the value of y? How do I find the value of y? I have a point on the curve whose x value is ln 5. What is the corresponding y value? How do I find it? Yeah? You replace x by where? In the derivative or in the original function? In the original function, very good. So at the point, the tangent line is horizontal at the point x is equal to ln 5. What is the value of y? It's e to the ln 5 minus 5 ln 5, right? So what is that? This is just ln 5. E to the ln 5 is 5. So it's 5. 5 minus 5 ln 5 is just 5. 1 minus ln 5. Okay? Is that clear? Everybody, is that clear? Any questions? Please raise your hands if you have any questions on this. Okay, I'm just going fast with the algebra. I hope I didn't mess it up. I think it's good. Okay, are we good? Yeah? Any questions? Questions here? No? No? Okay, great. Awesome. Now, any questions? So far so good? Okay, great. Now, I want to find the point where the tangent line is parallel to the line 17x minus y is equal to 72. Of course, here I need to find the slope of this line, right? If two lines are parallel, what can I say about these two lines? That they have the same slope. Now, what is the slope of this line? How do I find the slope? How do I find the slope of this line? Everybody? Yeah? The derivative of the line, 17x minus y is equal to 32. Okay, sure, but let's not use sophisticated technique. Let's go back to high school. How do I find the slope of a line? In the back? Coefficient of the x. Coefficient of the x provided? And provided I isolate them. Right? That's very good. It's the coefficient of the x provided I write it this way. Let me rewrite, where am I writing here? Right, I mean, saying the coefficient of the x is a good answer, provided you write it as in the form y is equal mx plus b. Right? If you, for example, if you multiply this equation by 2, you get 34x minus 2y is equal to 144. Did I change my line? I didn't change my line, but the coefficient of the x is, I doubled it here, okay? But I also doubled the coefficient of y. So let's see how to do that. So, I mean, very good point. Maybe, may I change it? May I change it? Is it too late to change it? Yeah. Let's see, let's rewrite it. It's a very good point, actually. 34x, I didn't change the answer. 34x minus 2y is equal to 144. Okay? So in that case, how do I find the slope in that case? Sorry about that. That was a very good point. How do I find the slope in that case? I isolate the y, and I write it as the form mx plus b, right? If you do that, what do you get? Y is equal to what? So b, 34x minus 2y is equal to 144. This implies that y is equal to 17x minus 72, right? Do you agree or not? Okay, what is the slope of this line? 17. So what do I need to find? I need to find the tangent line parallel to, I need to find the point at which the tangent line is parallel to this line. How do I solve this? How do I find the point? I take the derivative, yeah? I said it equals to 17. Very good. Are we good or not? Yeah, so dy by dx is equal to 17. Into d to the x minus 5 is equal to 17. So I have e to the x is equal to 22. So what is x equal to? X is equal to ln of 22. So the point, the tangent line. Y equals e to the x minus 5 x has slope 17 when x is equal to ln 22. And what is y in that case? Y is e to the ln 22 minus 5 ln 22, so it's 22. Well, let's write it, e to the ln 22. So what is that? X is ln 22. And what is y equal to? 22 minus 5 ln. Okay, great. Are we good? Is that clear? So please be comfortable with these types of questions. It's a very good. These are very nice midterm questions. Okay, great. Any questions thus far? No? Awesome. Great. Maybe let's do one more actually. I don't know if we should we do more example on this normal line business? Let's do a normal line example. Okay, I'll either have to raise upstairs and bring it down, or I have to raise here. What do you guys want? What do you guys want? I'll raise here. Okay, let's. Find the equation of the normal line to y equals let's see, what do we need? Let's put sin x over f of x as a point where x is equal to pi over 3. Now, what do I have here? What is the function I'm looking at? What is the curve? It's y is equal to sin x over f of x, right? Now, what do I need to find here? I need to find the derivative of sin x over f of x at pi over 3. Is that the slope of the normal line or not? No. That's the slope of the tangent line, right? Now, if the slope of the tangent line is non-zero, hopefully it's not. Hopefully it's not. I didn't do the calculation. If the slope of the tangent line is non-zero, what is the slope of the normal line? It's minus 1 over the thing I obtained, right? Now, if the slope of the tangent line is 0, this means my tangent line is horizontal. So my normal line will be vertical. Okay? So what you have to do is just compute dy by dx at x equals pi over 3. So it's dy by dx at x equals pi over 3. What is dy by dx? Or let's write just dy by dx here and then plug in pi over 3. dy by dx, who wants to help? Who volunteers? Any volunteer? Any volunteers? No? Someone else? Someone else? No volunteer? Yes? Let's. It's the. What rule do I have here?
Yes.
Okay. So.
S prime. No, sorry.
Go ahead. No problem.
So it's x times f of x.
Yeah. Very good.
F prime of x times sin x over f squared.
F prime of x times sin x. Very good.
Over f squared.
Over f of x Thank you very much. Yeah, derivative of sine is cos, sine f. Okay, very good. Now I have to evaluate as x is equal to pi over 3. What do I have? I just have cos pi over 3. Oh man, I mean I should have put pi over 4. Anyways. F of pi over 3 minus f prime of pi over 3 sine pi over 3 over f pi over 3 squared. Very good. Let's find the value of this thing. What's cos pi over 3? Cos pi over 3 is cos pi over 3. Pi over 3 is 60 degrees. 1/2. Very good. Thank you. It's 1/2. What is f pi over 3? Times 2. Very good. I got this one right. Okay. Minus, what is f prime pi over 3? 1. Sine pi over 3. What is sine pi over 3? Root 3 over 2. Right? I got this one wrong. Anyways, I need to be rational. I forgot. Anyways, then what do I get? F pi over 3, what is that? It's 2 squared, which is 4, right? Right? Yeah? Are we good? Yeah. Okay, so great. Let's do that. This is 2 minus root 3 over 8, right? Yeah? You see that? Bring the 2 down. You get 2 minus root 3 over 8. Oh, 1 minus root 3 over 8. No, that's good. 2 minus root 3 over 8. Yeah. No? Is that good? 2 minus root 3 over 8? Factor the half out. You get 2 minus root 3. Right? Over 4. Yeah? Sure, you cancel the 1. You get 1 minus root 3 over 2 over 4. I'll roll it this way. Great. Are we good here? Is that good? Yeah. Okay, this is the slope of the tangent line. First of all, is this number 0? Is this number 0? No. So the tangent line horizontal in that case. No. So what is the slope of the normal line? What is the normal line? The slope of the normal line is what? It is minus 1 over this, right? It's 8 over 2 minus root 3 minus that, right? So the normal line y equals, let's see, sine x, f of x at x equals pi over 3 is so the slope of the tangent line is 2 minus root 3 over 8. So the slope of the normal line is y minus the reciprocal of this, right? Times x minus pi over 3 plus f of pi over 3. What is f of pi over 3? F of pi over no, that's not f of pi over 3, right? I'm looking at sine pi over 3 over f of pi over 3. What is sine pi over 3? Sine pi over 3 is 1/2 over f of pi over 3, which is 2. So this is just y, or let's do it one way. Sine pi over 3 is root 3 over 2. You see, it's very good to remember the trick identities. Try to draw the circle every time, because you can mess them up very easily. So if x is equal to pi over 3, y is equal to sine pi over 3 over f pi over 3. This is root 3 over 2 over 2, which is root 3 over 4. Okay, so far so good. Is that clear? Yeah? Are we good here? No. I mean, I messed up the numbers, so it's better to simplify. I think you won't get anything else. Okay. Now in a multiple choice, I may just rationalize the denominator, so you have to get I mean, yeah. Anyway, great, awesome. Yes. Where? Where is that? Here? So I have sine over f. So the derivative of guys, the derivative of sine is cos. It's cos times f minus derivative of f prime times sine. Okay? Oh, okay. Very good. Okay, great. Any questions thus far? Any questions so far? Should we do like some examples or yes? Guys? Yeah? Root 3 over 4. So what is the equation of the normal line if you have a curve y is equal to g of a and g prime of a is non-zero? It's 1 minus g prime of a plus g of a, right? G of a, what is that? This is the value of the function at the point where x is equal to a, right? Plug in x equals pi over 3 here. Sine pi over 3 over f pi over 3. Root 3 over 2 over 2. Root 3 over 2. Is that clear? Great. Awesome. Awesome. Great. Maybe let's do one more. Let's do one more before we start a new thing. Can I erase this now? Everybody, can I erase this? Okay. Find the values of a and b such that, okay, who volunteers for a number? Who wants to give a number? Yes. 13. Okay, thank you. Such that, let's see. Such that f of x squared ax plus b is differentiable on R. Okay, I'm doing some practice because I think we're slightly ahead. Not slightly, we're very well ahead. I mean, I taught this course in math. I taught this course maybe the first time I taught, and then to my memory, when we had maybe at the end of September we started the definition of the derivative. So like we're a bit ahead, but it's good. We can do some more practice. Great. So let's have a look here. Now notice, f is composed of two functions, right? I have a polynomial and I have two polynomials, right? One is a line and one is a parabola. We agree or not? Yeah. Now, is the polynomial differentiable everywhere? Yes. Is the line differentiable everywhere? Yeah. So where is the only possibility where f is not differentiable? 13, right? So since x squared and x equal ax plus b are differentiable on R, f is differentiable everywhere except and possibly right? Yeah. You remember we did this sort of this type of exercises to assess whether or not a function is continuous, right? You remember that? We had like a function, the piecewise defined function, right? You remember this? Yeah. And then we said that if it's composed of parts that are continuous everywhere, we said that the only possible points where f could be discontinuous is the points where it changes. And here it's the same thing. Great. Possibly 13. Great. Now, how do I find it? How do I check that f is differentiable at 13? Now, let's think a bit. How many unknowns do I have? How many unknowns do I have? 2. Great. Now, you know, usually when there's a problem like that, usually it's a well-defined problem. We won't trick you. Okay? We will not trick you. That, you know, there are no values. If the question is find the values of A and B, it means there are only 2 values. Okay? Great. Now I have 2 unknowns. How many equations do I need? 2 equations. Great. Let us try to find one equation from what you know before. Now, in order for f to be differentiable at 13, if f is differentiable at 13, there's a word missing here. If I have a function that is differentiable at 13, what can I say about it? Yeah? It's continuous at 13, right? It's continuous at 13. Hence, the limit as x goes to 13 of f of x. Well, let's do it this way. Great. Now, as x approaches 3 minus, what is the limit of f of x? If x is less than 13, what is f of x? X squared. So the limit as x approaches 13 minus of x squared is equal to f of 13. What is f of 13? Just 13a plus. Great. What do I get from this equality? Limit on the left is 13 squared, 169. Limit on the right is just equal to 13a plus b, right? Both of these are. So 169 is equal to 13a plus b. I hope the numbers are going to be nice. They don't look like, well, no, they'll be nice. They'll be nice. They'll be nice numbers. Let's see. Okay, great. This is the first equation. Great. Let's write this as 1. Or you know 1. Well, let's keep it as it. Okay, great. Now, if I have f to be differentiable, what does it mean for f to be differentiable? That the limit of f of x minus f of 13 over x minus 13, what can I say about this limit? This limit, 8, this, right? We also need the limit as x approaches 13 of f of x minus f of 13 of x minus 13. That you also need that exists. Now, if it exists, this means it's a real number. And what can I say about these two things? Okay, great. What is f of 13 here? It's 13a plus b, which is equal to 169. You agree? So you can replace both of them by the respective, like, in that case, you agree that if you write 169 or 13a plus b, it's going to be the same thing. You agree or not? Yes. So, let's write here f of 13 is 169, which is equal to 13a. Great. Now, let's look at the limit as x going to 13 plus of f of x minus f of 13. What should we have here? What is f of x as x is bigger than 13? It is just, no, x is bigger than 13. X is bigger, it's ax plus b, right? It's ax plus b. Now, what is a better expression to use here for f of 13? 169 or 13a plus b? I mean, you can use 169, you can use either. What do you guys prefer? Both of them are good. What do you guys prefer? 13a plus b. Let's use 13a plus b. Is that good? Minus 13a plus b, so I factor the a out. Yeah, over x minus 13, that's good. Is equal to what? To the limit as x goes to 13 minus. Now, f of 13, what expression do you want to use here? 13a plus b or 169? Both of them are the same, but which one do you want to use? Do you have any a's and b's in the first, in 13 minus? Or you just have x squared? Do you want to add in unknowns? No. So let's just use the correct value. 13 minus x squared minus 169 over x minus 13. Great, let me continue. Blah, blah, blah. Oops. Can I write here? Okay, what is that? This is just the limit as x goes to 13. The b's will cancel out, you agree? B's will cancel out. I can factor an a out and I get x minus 13. Convince yourself that you can do this. That's very nice. And then here on top, what do I get? I can factor x squared minus 69 over x minus 13. So I can factor 0 over 0. Factor this up. What do you get? Great. So here, what do you get? You get a is 26. You agree? And what is b? B is 169 minus 13a. Oh, wow. Okay. 13a. 26 times 13. What is that? 26 times 13. How do you do that? So 13 times 25. What is that? So it's 1300 divided. No, you don't know how to do this. So 13 times 25. So 13 times 100. It's 1300 divided by 4 plus 13. Yeah? No? What's 13 times 25? Or what's 13 times 26? Let's see, maybe we can do it another way. So, this is nice. So factor out. We get 13 times 13 minus 26. This is minus 169. Is that good? Is that good? Yeah? Great. Awesome. Okay, great. Awesome. I'll post some exercises on these things like that. You should be able to, yes, did I mess it up? The x minus 13 will cancel out. What do you get? 8. Factor this out. X squared minus 169. Okay?
Yeah.
Is it okay if we just use the derivative law?
No. No. So what do you want to say? You want to say f prime limit as x goes to 13 minus of f prime on this side?
Well, you can just take the derivative when x is greater than 13, take the derivative when x is less than 13.
Yeah, and then?
And then you'll have you make sure the derivatives equal each other, that is differentiable.
That's you're checking for continuity of the derivative. You're not checking for differentiable.
But if the derivative, if the Derivative function is continuous, therefore it's differentiable.
If it's continuous, that's not necessarily differentiable. No. Okay? If it's differentiable, then it's continuous. Okay? So you should do it this way. Okay? So please don't try to invent your own method, you know, as shortcuts. Okay? This is how you're supposed to do it. Okay? So I see that many of you want to take the derivative on this side and the derivative on the other side and set them equal. Great. I mean, in that case, this is what it is. But in general, it may not be the case. Okay, great. Yes, sir. Would you please read the word? A is equal to 26. I agree that the left-hand side limit is 0. The right-hand side limit, what is that equal to? 13 plus 13. Okay? Great. Now let us move on to the chain rule. So far, we've differentiated very simple functions. Y is equal cos x, y is equal cos x squared, y is equal cos x. So far, we differentiated xn and real. I don't know, sin x, and blah, blah, blah. Right? We differentiated easy functions. Now, what if we have a composition of two functions? So what if we have y is equal to, let's say, e to the x squared? How do I take the derivative for that? Do I have to find a new rule every time? Or if it's e to the x squared, it's the derivative of that, it's this? No. Maybe there is one rule that encompasses a lot of derivatives. So this is the chain rule or the composition rule. So if y is equal to f of g of x, okay? Y is f of g of x, then dy by dx, I mean, the book proves it. Maybe I'll give a small a sketch of a proof for this one. Then dy by dx, what is this? This is just, you take the g, you differentiate it, very easy, right? Differentiate the g, and then f prime applied at g of x. Let us do a small example here. If y is equal e to the x squared, I can write y as f of g of x, right? What is g of x here? What is the last function I'm taking? F of x is e to the x, right? And g of x is x squared. You see that? If you take f of g of x, what do you get? If you take f of g of x, what do you get? You get e to the x squared, right? Which is equal to y. So y is f of g of x. So what is y prime in that case? Or let's look at f prime and let's look at g prime. What is f prime of x in that case? What is f of x? F of x is e to the x. What is f prime of x? G of x is x squared. What is g prime of x? 2x. 2x. So d by dx of e to the x squared. What is that? This is just g prime of x times the f prime, apply the g of x. What is f prime, apply the g of x? So replace the x here by g of x. What is the g of x here? X squared. So this is just g prime of x is 2x times e to the x squared. Is that clear? It's just a plug-in formula. Of course, we'll do more of this on Wednesday. Okay, great. Thank you very much.